Okay, let's create a double pendulum. Um, we'll also demonstrate some of the streaming animation. We'll start, this is a default screen, and so we'll just select the cube, and we'll make this a clamp, and then we'll just add a revolute hinge and a mass. Once we have that in place, then we'll be able to uh, demonstrate it with a single pendulum, and then we'll go for a double. So let's start with a joint, a clamp, and the clamp is here. Um, the Next we'll add a body, and then we'll put them together with a revolute hinge. So let's add a body. We need to give it an inertial matrix. Here we are. And there's our body. We'll move it over into, let's say, the x equals 4 location, right? So we moved it this way. Let's come over here, and so we can see this body. Now we need to create the hinge. So we'll have the body. We press the shift key. We right-click on what is our clamp, and here we'll add the joint, which will be the revolute hinge. Okay, there we are. Now the hinge is not properly oriented, right? So we need to rotate it. So for that, we could just do press R for rotate, X for about the x-axis, type in 90. Now we have it. So we're ready to create our simulation. I'm adding one more item though. So I'm select all with the A key, and then none with the A key again. That toggles all. And I'm adding something new here, which is our output stream animation. So we'll be able to see this running real time. So now we create our initial value problem, and we just need to save it at a location the first time, run the simulation, and let's see, that should work. So, oh, we need to add some gravity. That's why it didn't work. So let's add some gravity. So environment, gravity. The vector, we need a new vector. It'll be in the -z direction. And we'll scale it. We'll scale it by 9.81. And there we go. So now we have our gravity and our drive. Well, this needs to be a unit drive because gravity is always in play. So there we go. So we have our vector, our drive. Now, when we run this, boom, see? There we go. It swings. Nice. So now, very simply, by the way, with the 5, pressing the 5 button, I can go from orthogonal to perspective, right? So, and then I can press the 1 key to go to, that's on the num keypad, to go to the side view. So now, what we'll do is take this body and we'll duplicate it. So we'll duplicate the body. We'll make a full copy of it within the current scene. And now we'll grab it in the x direction 4. So there it is, right? So we take that and we'll connect it to the first body by the same thing, a revolute hinge. Now we'll see that needs to be rotated as well. So we'll rotate it about the x-axis, 90 degrees. And if we go through, we see not only is that a revolute hinge, but it's also, of course, well, there's the first body, and there's the second body. So we've got both the bodies. We've got the where they're pinned to. We can make that look like the clamp that they're pinned to. And then if we create the initial problem, run it, boom, all right, so we see the thing go. So let's look at that from the side and orthogonally so we can run the simulation. There we go. Now, the next thing we can do is, let's say we want to have it run forever, right? Instead of the 10 seconds, we just get rid of the final time and run the simulation. And there we go. It's running. We can look at it in perspective while it's running. We can zoom around and pan and take a look at everything, all right? So there we go. So it's doing what it needs to do. To stop a continuous animation, press the escape key, and it'll go back to its original condition. What's nice here, just a couple of things to try out. You can just grab this, move it wherever you want, just to change the initial condition. Then we can again, recreate this, run our simulation, and now, they're bouncing around, doing some interesting things. We'll press escape so that we save it. Now, we can write our keyframes. We'll write them, let's say, every roughly 100 keyframes. And what this does is takes the animation that we just saw, and one of the things we want to do is change this distance, make it around, we're up to around 300 or so. So we'll go to 300 so we can see all of this. And we start at the beginning and we animate it, and you can see the behavior that we just simulated. We've captured it, right? Now, then if we'd like to see a graph of this, we can, let's say, take that object and come over here and plot the node. And we can, let's say, we want to plot its X and Z locations. There we go, X and Z for that object. Let's say we want to go to a joint. Let's say this revolute hinge. Well, more interestingly, we can go to the other revolute hinge, this one here. And let's say we want to plot the data for the revolute hinge. Let's say we want the angular displacement about the y-axis. And there we go, right? And that's the whole behavior. So that's the simulation. In the next simulation, we'll show the crank and slider, and not only will we have streaming animation, but we'll do streaming events so we can drive it from the keyboard. Okay, that's it for now.